We are going to discuss one more important concepts of probability distribution, that is binomial distribution. Okay, before we starting the binomial distribution, I am going to explain one important definition called as Bernoulli trials or repeated trials. Okay, the definitions goes like this: a random experiment with only two possible outcomes categorized as success and failure is called Bernoulli trial. For example, if you toss a coin and we have only two possible outcomes, head and tail, or if you consider any one factory production on some particular item may be defective or non-defective. Okay, such type of problems will comes under the Bernoulli trial. Okay, note the probability of success is same for each trial, that is, remember this is important point. Okay, now moving to Bernoulli theorem, the probability of x successes out of n trials is equal to ncx p power x q power n minus x, where p is the probability of success and q is the probability of failure. Remember, this notation stands for ncx. Okay, that is nothing but your ncr. In place of r I am using x, that's it. Okay, next, now I will consider one example to illustrate this definition. Okay, I will consider tossing a coin 3 times and we wish to know that the probability of getting 2 heads. Okay, the possibilities are follows like this. So we have total 8 possible outcomes for 3 trials, that is HHH, HHT and so on up to TTT. Okay, in these 8 possible outcomes we have only 3 possibilities to our favorable event, that is HHT, HTH and THS, that is probability of getting 2 hits. Wherever 2 hits are there, that I will consider my success case. Now therefore the probability of getting 2 hits is 3 by 8, means total number of possible outcomes is in the denominator and the numerator is total number of favorable events, that is nothing but 3 by 8. Now the same example we'll discuss by using the Bernoulli theorem. Okay, now clearly we have the number of trials n is equal to 3, that is tossing a coin 3 times. Okay, the number of successes is, if I getting 2 heads, that is my success case, therefore x is equal to 2. The probability of success, that is probability of getting one head, probability of getting head from one trial is 1 by 2, and probability of failure is q is nothing but 1 minus p, that is also equal to 1 by 2. So from Bernoulli's theorem we have the formula ncx p power x q power n minus x. Substitute the values of n, p and q and along with the value of n will and simplify this expression. Observe the final result, it is same as what we got in the previous step. Okay, so this theorem is very useful whenever if you have a tossing a coin 1000 times. So I can't able to write the sample space for that. At that time directly I will use the Bernoulli trial. Okay, remember Bernoulli trial, if you want to use, means the probability of success for each trial will be the same. Okay, now moving to binomial distribution. Okay, now p is the probability of success and q is the probability of failure. The probability of x successes out of n trials is given by p of x is equal to ncx plus into p power x into q power n minus x. It's nothing but a Bernoulli theorem. Okay, the same thing I am using here, and the mean and standard deviation of the binomial distribution are given by mean mu is equal to np and variance v or sigma square is equal to npq and standard deviation is root of npq. So the derivation is not in our syllabus, so straight away I given the formulas. Remember, these 4 formulas are very much important to solve the problems. Now the applications of binomial distribution. So where you are going to use this in? The first one is the number of defects in a sample from a production line. That is, if you consider any one factory, it is producing some items, means it may be the defective or non-defective. So such cases will come under the binomial distribution. Estimation of reliability of the systems and radar detections and etc. Okay, now before going to solve the problems, we must know some important points here. Okay, here you must give the words and notations, very much important here. So whenever if you found at least r means any real number here, at least r means you must take x is greater than or equal to r. That means starting with r, that is starting point is r and ending point is the given number of trial, that is the value of n. At most r means that is the maximum value. So it between 0 to r only, that is greater than r you can't able to consider. R or more than r means again it is nothing but at least greater than or equal symbol you are going to use. More than r means strictly greater than. Okay, and we know that the probability of the maximum value of the probability is 1. Okay, now whenever I have p of x greater than or equal to r, now I think already we've done the problems on random variables. We have done the problems regarding p of x greater than 1. Since they are given a table is a limited one, since 4 to 5 values are there, greater than 1 means I can able to go with p of 2 plus p of 3 plus p of 4 like that. But whenever if you have r is equal to 100, p of greater than r means I can't able to go with 0 to 100 there. At that time I will go with the reverse order, that is 1 minus p of x less than r. Just observe the inequalities here. Greater than or equal symbol is there means 1 minus p of x strictly less than r. Whenever only strictly greater than is there means then equality symbol you have to consider. X greater than r means 1 minus p of x greater less than or equal to r. Similarly for less than or equal relations I given these things. So before you starting the problems, give the important for these 8 points, that is. Okay, now moving to the first problem. Here they are given that the problem is this: when a coin is tossed 4 times, find the probability of getting exactly 1 head, at most 3 heads, and at least 3 heads. The solution is like this. Given the value, that is 4, we are tossing a coin 4 times and x denotes the number of heads. Okay, now p is equal to probability of getting head from one toss, that is 1 by 2, and q is equal to 1 minus p, that is also equal to 1 by 2. Now write the formula of binomial distribution, that is p of x is equal to ncx p power x q power n minus x. Substituting the values of n, p, q, will get 4cx 1 by 2 whole power x 1 by 2 whole power 4 minus x. Now the first sub question, exactly 1 head, that means exactly means x is equal to 1. Substitute in equation number 1 x is equal to 1 and simplify by using the calci, will get the final answer as 0.25. The second sub question, at most 3 heads, that is x less than or equal to 3. That starts with p of 0 plus p of 1 plus p of 2 plus p of 3. So substituting the values of x is equal to 0, 1, 2 and 3 in equation number 1. So we'll get this particular expression, simplify in the calci carefully, and we'll get the final answer 0.9375. Now at least 2 head, at least means it's a starting number, that is x should be greater than or equal to 2. Okay, I'm going with 1 minus p of x less than 2, that is 1 minus p of 0 p of 1 less than 2 is there means always starts with any number is there means the minimum value should be 0. You have to start with 0 and 1. Okay, then substitute the values of x is equal to 0 and 1 in the question number 1 and simplify, you'll get the final answer as 0.6875. Now the second question is, the probability that a pen manufactured by a factory be defective is 0.1. If 12 such pens are manufactured, what is the probability that exactly 2 are defective, at least 2 are defective, none of them are defective? Okay, write down the first value of n, that is there are 12 such pens they are given, n is equal to 12 and x denotes the number of defective pens, therefore p is equal to probability of defective pen, that is given as 0.1, and q is equal to 1 minus p, 0.9. Once you get the values of n, p, q from substitute in the binomial distribution formula, ncx is equal to p power x q power n minus x, that is 12cx 0.1 power x 0.9 power 12 minus x. Once you substitute this one, going to the first sub question, exactly 2 are defective, that is x is equal to 2. Again from equation number 1, substitute the value of x is equal to 2 and simplifying the calci, will get 0.2301. The second sub question is, at least 2 are defective. At least means greater than or equal to 2. Now p of x greater than 2 is there and total number 12 is there. Greater than 2 means starts with 2, p of 3 plus p of 4 plus p of 5 like p of 12. So I can't able to find the 10 values. For that I will go with the reverse order, 1 minus p of x less than 2, so that I will get only the 2 values, p of 0 and p of 1. Okay, that is substitute x is equal to 0 and 1 in the equation number 1 and simplify, will get the value is equal to 0.3410. Okay, none of them are defective means x is equal to 0. Again substitute in equation number 1, try and simplify, we will get 0.2824. Okay, the third problem is the probability that a person aged 60 years will live up to 70 is 0.65, and what is the probability that out of 10 persons aged 60, at least 7 of them living up to 70 years. Okay, given there are 10 persons, therefore n is equal to 10, and x denotes the number of persons aged 60 living up to 70 years. Also, they are given the value of p is equal to 0.65 and q is equal to 1 minus p, that is 0.35. Now, substitute in the formula of these values, we will get equation number 1. Now, we need to find here probability of at least 7% living up to 70 years. Okay, observe the last sentence, that is find, they are asking find the probability that out of 10 persons aged 60, they are already on 60 years, in that how many will be live up to 70 years, that is at least 7 of them will live up to 70, that is okay, x greater than 7. Here don't go with 1 minus, because if you go with 1 minus means 0 to 6 you need to evaluate its 7 values. Compared to that one, this is easy. So start with 7, 8, 9, 10, substitute in equation number 1 of these values for x and simplify, we'll get the final solution. Okay, then moving to the next problem, the number of telephone lines busy at an instant of time is a binomial variate with probability 0.1 that a line is busy. If 10 lines are chosen at random, what is the probability that no line is busy, all lines are busy, and at least one line is busy? Okay, given that there are 10 lines, therefore n is equal to 10. X denotes the number of telephone lines are busy, and also given p is equal to 0.9, that the probability that the line is busy. Q is 1 minus p, that is 0.9. Substitute these values in the formula and call that as equation number 1. Okay, so first sub question, no line is busy means x is equal to 0. Put the value of x is equal to 0 in equation number 1 and simplify, we'll get 0.3487. The second sub question is all lines are busy. So put x is equal to 10 in equation number 1 and we'll get 0.1 power 10. If you have, because since I think so few of the students are fixing for 4 decimals, if you evaluate by using the calc, you will get 0.000. Okay, since 1 power 10 is there means after the 10 decimal you will get the 0.1. So 1 is the solution, so that keep the term as it is, that is 0.1 power 10, keep the term as it is. At least one line is busy means x greater than or equal to 1, that is 10 lines are there. Greater than 1 means starts with 1, 2, 3, 4 like that up to p of 10 you need to calculate. Instead of that, 1 minus p of x less than 1 means okay, 1 minus p of 0. Simplify using the calc, you will get the solution as 0.6513. At most 2 lines are busy, that is less than or equals. Start with 0, 1 and 2. Substitute in equation number 1 and simplify, we will get the final answer as 0.9298. Okay, moving to the assignment questions. Okay, based on whatever we discussed in the video, similar to that I given the 3 questions here. Solve it in these 3, and again in the next video we will discuss some more problems on the binomial distributions only. Thank you.